Okay, YouTube, in our last video, we explored the mean, the median, and mode for a data set and kind of interpreted what they mean. In this video, we're going to work on how to organize a data set so that we can kind of see where the data lives. Okay, so when we work with sets of data, we often like to be able to tell what numerical, and I use a word here, neighborhoods that each datum lies in. But in order to do this, we create what is referred to as a frequency distribution here. Okay. So recall, of course, the word frequency, how frequent something is, how often it occurs, and how it's distributed. Essentially what we're going to be doing here is we're going to create a table for a set of data here, and we're going to be placing each datum into, and I'll call these like bins, if you were to sort things into bins, which bin it kind of lives in, what neighborhood it lives in, and we'll get a really good idea of kind of, what our data looks like. And when I say looks like, the only reason I say that is because we're going to take this bin information, or this frequency distribution information, see how our data is distributed across these bins. And we're going to create a bar graph out of it, or what we call a histogram. Okay. So we say in order to create frequency distributions, it's necessary to create a table that breaks the data up into intervals that we call classes. Okay. So you'll notice that my table down here says use the following table to construct a frequency distribution for this set of data. But what I've done is I've split these up into evenly spaced classes or numerical neighborhoods for which our data is going to lie within. Okay, so let's go ahead and read what this data set represents, and we'll talk about how you would use this table to distribute the data, but we'd say, or to show how the data is distributed. But it says consider the following data set. Let it represent the scores of 20 randomly selected students on a CNA quiz out of 20 points. So it says find the mean, median, and mode for the set of data first. Well, that is one thing that I'm interested in doing. And as far as finding the mean, median, and mode, I know that this data set has to be in order if I'm going to find the median at the very least. So let's go ahead and put these data in order. It looks like I see a minimum value of 3. We'll go ahead and circle this 3 here. I don't see any other single digits except for this 8 right here. So we say 3. Somebody got an 8 out of 20. They weren't having a good day. And then everything else is in double digits. So we have a 10. Any other 10s? So I don't see any other 10s. Do we see an 11? No 11s here. Okay. Do we see any 12s? Now here's a 12. We say 12 is in the data set. Any other 12s in this data set that we see here? Nope, but I do see a 13. So somebody got a 13 out of 20. Any other 13s in the data set? No. 14s? No. 15. We do have a 15. So we say 15. I don't see any other 15s, but I do see two 16s. So I'm going to say 16, comma 16. Okay, so any other 16s before we proceed on to 17s? So we say nope, we have two 17s right here. Any other 17s that haven't been circled? No, so we say 17, 17. Okay, so now on to 18s. Looks like we have one 18, two 18s, three 18s. So we have 18, 18, 18. We say 19. 1, 2, 3, 4, 5 19s. So we have 19, 19, 19, 19, 19. So this class did all right. And we say, okay, or this group of randomly selected students, we say 20. Whoops, I was thinking that there were 220, so I wrote 22. But we say, here's, I almost did it again. Here's our set of data. So if we're going to find the mean, let's go ahead and check out the mean here. It's very important that you add up all of the data first. Clear. I'm going to take my time on this one. We say 3 plus 8 plus 10 plus 12 plus 13 plus 15 plus we had two 16s, so 16, 16, 17 happened twice. We have 18, we had 3 of those, 1, 2, 3 18s. We had 5 19s, so 1, 2, 3, 4, 5 of those plus 20 plus 20. So the sum of our data is 316. So I'm going to write this down. We say the sum of our data is 316 total points, and the number of students that took this was 20. So our average, our x bar, is going to be 316 over 20. We should write it this way first. And we're going to go ahead and take that 316 and divide it by 20. So we say divide this by 20. So the average score is about a 15.8 point score. Okay, so when we say, how about the median? We say, we'll count in. We say 1, 2, 3, 4, 5, 6, 7, 8. Count in this way, 1, 2, 3, 4, 5, 6, 7, 8. Now we'll take our time. We say, oh, here, here, and then we land splitting the difference between 17 and 18. So it's going to be the median of those two. So we say in the median value was 17.5 points. And in terms of the mode, okay, we say the mode. looks like a 19-point score. So they're all relatively in the middle of our data set, all of these measures of central tendency, okay? But the most common is 15.8, the middle score, half bigger, half smaller than 17.5, and then we say 19 was the most frequently occurring, which I'd be happy with if I was a teacher. So we say, excuse me, if we're going to organize this into classes, the one thing I want to mention here is, again, is that we do have this 4 and under class, but we say how wide is each class? We talk about the class width. And from 5 to 8, I get a lot of people say, well, that's a class width of 3, but I would say that, well, how many data would fit in here? Well, 5, 6, 7, 8. That's actually 4 data that fit in this class. So what we're going to say is, to find the class width, what we do is you say that the distance from here to here is 4, and the distance from here to here is 4, and from here to here is 4. So the class width here is 4 on each of these. And the same is true for these what we call upper class limits as opposed to the lower class limits. But we're just going to go ahead and organize our data in this table. So we say putting them in order is a beneficial thing, because as we go through this, we say, well, 3, where would 3 belong? We're going to start by making a tally first. And so we say 3 would belong in this 4 and under scoring class. But 8 would belong in the 5 to 8 category. So we'll put a tally here. 10 would belong between 9 and 12. So we say 10. Then we have 12 would belong in this class also. We kind of want to line these up, you see. We say 13 would belong 13 to 16. Then we had 15. We had 2 16s, so I'll put those on here. So 2 16s. Once we get to 17 and everything after, so they're going to belong in the 17 to 20 class, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data that were here. So we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we want to organize it with a tally first, but when we get over here to frequency, we're going to give a numeral value to these tally values. So we say 2 is the numeral for 2 tallies here, and we say 4 tallies is 4, and then we say that we had 12. One thing I do want to mention here is that when you add up all of the frequencies, we should have the total number of data, which if you add up 12 plus 4 is 16, plus 2 is 8, plus 2 more is 20. And so we had 20 students taking this. So I know that I've hit all of my data, but that's one thing you always want to check. So now that we've organized it thusly, I say over here we can often represent our data from the frequency distribution. We can see how our data is distributed with frequencies here, but in a histogram. You hear a histogram a lot. Histogram is a fancy word for a bar graph. But when you make a bar graph, what we are doing is we are, labeling our axes with 2 bits of information. The intervals, or the classes for our data, as well as the frequency. And I'll just go ahead and be honest with you here. The intervals are always what will go on your x-axis. And in this case, we'll say, this is CNA quiz scores. We want to give this a title, scores 20 students. And when we label this axis down here, we're going to label it. We say scores, and you always want to put units. We say in points. Okay. So now, if you have a paper in front of you, you could actually turn your paper sideways. But we're actually going to write the neighborhoods down here, and I usually write them vertically. But just to emphasize this here, we're going to say, okay, I'm going to put spacers in between here. But we say that this category right here, down here on this axis, would be our 4 or under. So we say 4 or under belongs here, and I'll write it diagonally, so it kind of lives here. And then we say 5 to 8 would live here, and then we say, okay, well, the next one would be 9 to 12 would live here, and then we say 13 to 16 would live here, and then we have right here, we would have the 17 to 20 class. 17 to 20 would live here. That bar would live there, and we wouldn't need any of this other information out here. And then as far as what we're graphing, what we're doing is we are graphing the frequency for each class, or how often we had data that lived in that class. So I notice that the highest frequency, and this is important, is 12. And so I notice also that I count 1, 2, 3, 4, 5, 6, 7, 8. I'm not going to be able to go by ones. So using the highest frequency, you're going to have to choose a scale here. And I'm going to say that, well, we're probably going to have to go by 2s. And if I do this, I'm going to say 1, 2, 3, 4. I'm going to make this bigger than the rest. And you notice that I'm just going to call that 10. It is no reason, there's no reason why we need to label every one of these. We'll just label a benchmark that helps us navigate. So as far as how to make our histogram goes, what we're going to do is we're just going to make bars in each of these classes that correspond to the frequency in that class. So for instance, the first 2 classes had a frequency of 1. So 4 or under, we only had 1 quiz score there. That's halfway between 0 and 2. And the same thing here. So we'd say that our bars look like this, and it's totally appropriate to color in the bars, okay? We say 1 and 1. The next class had a height of 2, so we say 2 here. And then we say the next class has a height of 4, so we say 4. I say, okay, so here's my bar that is a height of 4, and then the last one has a height of 12, which is this right here. We say 12. So if we color this in, what we do is we can ask some questions now. We say, what conclusions can we draw from our set of data? Well, I would conclude that most students were in the upper end of this distribution, or had scores that were like 13 or higher is what we could say. Or most students were 17 or higher, we could say that. Also this, we say, where was the mean located with respect to the rest of the data? Well, the mean, remember, was 15.8. So we would say that if this is 13 to 16 in this little neighborhood right here, I mean, I suppose I could pull out a red pen. But we'd say, okay, so 15 would be like right below 16, so we say that the average score was somewhere right in here, okay? And then we would say, well, what about the mode? The mode was 19. You could see that corresponds to this highest occurring bar, 19 be about right in here. And then the median was 17 and a half, that'd be about right here. So we'll talk about skewness later, but this is a very left skewed graph because we had some really low scores that threw off, say, our average here. Cheers.